This is the second part of our lesson. Please take a second and write down all three of these examples, including the little title here on every one of them and the actual problem. Okay, please pause the video and take the time, maybe 1 or 2 minutes, and write that down. All right, now, when we talk about our x being on top of our fraction, this is one of the 3 types of setups that you may see when you're working your trig problems out. When you do your setup, if you see x on the top, this is the exact problem that we just did in the bell ringer and we worked it out. What was our method to solve for x in this problem? In one step, we could just take our cross product and multiply. So if x is on the top, you are going to multiply cosine of 53 times 12. Okay? So I'm going to leave that one there because we already talked about it. We already seen that example. Let's move on to number 2 and let's look at something new here. What if you had x that ends up on the bottom of your fraction? Can this happen? Yes. And you saw it on your homework last night on the back side of 7-4. Sometimes your x variable ended up on the bottom. Okay, so let's take this example, and I'm going to show you how we can work this example to solve it for x. Let's think about this proportion idea again. We can always take this number, sine of 17, and put it all over 1, and we have not changed anything. That helps us be able to do this cross product. Okay. But take a look at this. This is not so easy to just cross multiply one time on this one. Take a look here. Your easy cross product, so to speak, on this one is 4 times 1. Okay? We're going to do one cross product, set it equal to the other cross product. Okay, here we go. Let's do it. 4 times 1 is 4. Please write this on your page. Okay? Now, set that equal to your other cross product. And that is sine of 17 times x. Okay? Now, can we simplify that as of right now? No, unless the only way we could simplify it is to get a decimal. Punch that sine of 17 in and get your decimal. I am not going to personally do that. If you like to do that so that you can get rid of those letters and you just want to see that decimal, that is a perfect way to do this. My only suggestion is if you change this into a decimal, do a lot of decimal places. Don't round it off real short. Use a lot of decimal places. Okay? The smaller number that you cut it off, if you cut it off like to 2 or 3 decimal places, it makes a little bit of an error in your final answer. Okay? So as many as you can write on there, you can just take the whole screen and write it down. If you want to change this to a decimal, be sure you have make sure you attend to that. Okay? But I'm just going to leave it like this. Watch. And also write it down. Here is your second cross product. Sine of 17 times x. Okay? Right? We're just multiplying it together. Don't know what x is, so we just keep it in there. All this is just some number multiplied by your x. This is like your coefficient. Now I'm going to just take a second and let me do it in a different color here. You guys know how to solve something like this. What if you had 8 equals 2x? What do you do to get x by itself in a problem like this? You just divide by whatever that coefficient is. Okay? Well, look at this. Sine of 17 is just some decimal number. It's being multiplied by x. So if we want to get x by itself, how can we get rid of sine of 17? Well, let's just follow our algebra process. Now let's just divide both sides by the sine of 17. It's just a number, just a decimal. Here's a big mistake that some students make. They want to take 4 and they want to divide it by just 17. That's not what we need to do here, because once you put 17 into this sine function, it now changes it into a different decimal. Okay, so this is your correct process right here. 4 divided by the sine of 17 is correct. You will never be able to get your answer if you leave off that sign. Okay, that's very, very, very important. look at the right side over here. This disappeared with each other because we're dividing something by itself. The only thing we're left with on this side is your x. So we just got x by itself. Now, let's just punch that in the calculator. Okay, so 4, do it with me, divided by sine of 17. Everybody needs to make sure you're getting some practice with this, and it would help if my calculator was on. Okay, let's try this again. I know you've never done that before. Stop laughing at me. All right. 4 divided by the sine of 17. There it is. That's all we need. Push enter. There's your answer. Okay, let's write it down. 13.6812, and it continues on. When you give your final answer at least 3 decimal places, don't round that thing off to 1 or 2. We need more, is always better. All right, if your variable's on the bottom, this is going to be your process. Let me just share with you a little shortcut here. I know you guys probably have better memories than I do, actually. And the more you practice with this, if you do lots of problems and you can just repeat it, then you're going to be able to remember it. It's not really memorization then. It's kind of like you've done it so much that you just know what to do. Okay. Here is your kind of shortcut trick. I'm going to erase this and go back to the original problem. Sine of 17 equals 4 over x. Okay, here's what we started with. What did we end up putting in our calculator? 4 divided by the sine of 17. Here is your consistency. Every single time you have the x on the bottom, when x is on the bottom, you are going to divide. Okay, but here's the thing. When you divide, if you're dividing, let's say 4 divided by 2, is that the same thing as 2 divided by 4? Can we switch them around and it still be the same? No. Division is not commutative. This does not equal the same thing as this. So you got to make sure you put the right thing in first. Okay, so here's the trick. Divide. The way I remember this is my numerator originally. Look at this. You see this fraction? What's your numerator in your setup? 4. Your numerator stays the numerator when you punch it in your calculator. 4 goes in first. And you're going to always divide that numerator by your trig. Okay? Here's what I'm going to write as notes down here. I'm going to say your trig is always on the bottom. Always on the denominator. Okay? Write it down so you don't forget. If x is on the bottom, you're going to divide, but it's very specific that you punch in the trig, make it on the bottom of your fraction. You're working 4, you're working with sine of 17. Make sure that sine of 17 goes in after you put your 4. All right. So there's your second situation. There is one more situation that you will see, and this is it. What if you have a problem? Let me draw a little picture for this one on my board here. What if you have a problem and you have an x that they want you to find that is inside your triangle? And let me go ahead and just kind of set this up the way that this problem would be. Okay. What if you have your x inside your triangle as a degree measure? This would be your setup. Okay, I hope you can agree with that. From here, we can get tangent of x degrees equals 8 over 6. But how in the world do we get x outside that parentheses and get it by itself? Okay, this just kind of has a trick method to it. You need to know the trick. If you know the trick, then you're good to go. Okay, so here it is. If x is inside the parentheses, you are going to use your second button on your calculator and whatever your trig function is. Now, let me say this. This could be tangent, it could be sine, it could be cosine, depending on what they give you in your picture. It's not always going to be tangent if x is in the parentheses. Okay? For any of these, it could be any of your trig here. Okay? So it doesn't have to be tangent on every problem, but for this one it is going to be. So whatever trig function you're using, that's the button that you're going to use on your calculator. Alright, so second is your yellow button on your calculator. Push that on, go ahead and do it. Push it on your calculator and push tangent. What pops up on your screen there? TAN -1. This is your inverse of your trig function. Okay? So when x is inside the parentheses, use the inverse trig. When x is inside parentheses, this is where you're going to use inverse of whatever trig you're using. How do you get the inverse? Use your yellow second button. This is just the process. It's going to work. Okay, if you have not punched in your calculator, take a second. Make sure your calculator's on. That always helps. Tangent. Oops, forgot my second button. Let's punch in second first. Got to do that before. And now hit your second button. And look what it pops up. Tangent of the -1 is there, and it does open a parenthesis for you. So what goes inside the parentheses this time? What do you think? Whatever is on the right side here. If it's a fraction, sometimes they might give you kind of a simplified problem here, and they'll have a decimal here. Doesn't matter what's over there. If it's a fraction, put it in there. If it's a decimal, put it in there. Whatever's on the right side goes right inside of parentheses. Okay, so here we are, inverse function of tan, and inside your parentheses, 8 divided by 6. Let's do it. Okay, here it is. And now just push enter, and that is your answer. Okay, 53.130.10235. We do have a unit on this one that we can put. What did we just find? Look at what we were looking for. What always goes right beside your trig? Your degree measure. So what can we put on this answer? This is in fact 53.130 degrees. Okay. All right. Here are the 3 different situations that you could see. There's no other situations that you'll see besides the x being on top, or the x being on the bottom, or the x being inside parentheses. Tonight on your homework, you will see all 3 of these different setups, and you need to use this sheet to go back and remind yourself how to solve it depending on what kind of setup you have. Okay. This is the end of the lesson. I am going to do one more short video to help you do some examples, so you can watch that after this.